Guys, in this video we will discuss the Poisson distribution. So first we have to know that what is Poisson distribution. The Poisson distribution is a discrete random variable, and we said a random variable x is said to follow a Poisson distribution if the probability mass function is given by probability at x is equal to r is equal to e to the power minus lambda into lambda to the power r by factorial r, whereas r is equal to 0, 1, 2 and 0 elsewhere. And here we have to know that this lambda is always greater than 0, and lambda is known as the parameter of Poisson distribution. So now there is a question that in which condition we use the Poisson distribution. We use the Poisson distribution for the following conditions. That is, the first condition is n tends to infinity. That means n tends to infinity means the total number of, that is the total number of n tends to infinity. That means the total number of experiment is large. Total number of experiment is large, and p tends to 0. That means which is that the probability of occurrence of an event that is very small. That's why we take p tends to 0, and at last np is equal to constant. And we have to here know that this variable lambda, this is known as the lambda is equal to np, whereas lambda is the parameter of the Poisson distribution. And we have to also know that the Poisson distribution is the limiting form of the binomial distribution. Poisson distribution is the limiting form of binomial distribution. So here we can use also for the same fact when we use the binomial distribution, but we have to keep in our mind that when we use the Poisson distribution, that is, suppose there are only two events will be happen, either success or failure, or happened or not to be happened, but the total number of experiment is very large. Number two, the occurrence of the event, that means that will be happened or not, that is very small, and we have to find. And since this np is equal to constant, right? As we know that the np is equal to the mean of the binomial distribution, and lambda is equal to mean of the Poisson distribution. In the next video we will show that how can we find the mean and variance of the Poisson distribution. So now let us solve one problem about Poisson distribution. So see here, there is a question that a car hire firm has two cars which it hires out day by day, and the minimum number of demands for a car on each day follows Poisson distribution is 1.5. So here given that then lambda is equal to 1.5, and then we have to find the probability of days on which neither car is used and the proportion of the days on which some demand is refused. That means here given that we have to find the probability that neither car is used, that means we have to find the probability of x is equal to 0, because if we say the random variable is x, the random variable is capital X, then for finding the probability of this that on which neither car is used, that means there is no demand on that day, that means on that day there is no hire for the car. So we have to find the probability of x is equal to 0, And we know that from the probability distribution that probability x is equal to r is equal to e to the power minus lambda into lambda to the power r by factorial r. And here r is equal to 0, so probability of x is equal to 0. Probability of x is equal to 0 is equal to, we can write e to the power minus 1.5 into 1.5 by 0 by factorial. Factorial 0 means 1 and 1 factorial 0. So the probability of x is equal to, that means the probability of that there is no card is used, that is e to the power minus 1.5. So similarly now we have to find that when we can refuse the demand. That means since we have two cards and we have to refuse the demand of the card, since all the cards are booked, that means we have to find the probability of x greater than 2. That means probability of x greater than 2 means we can write 1 minus p of x less equal to 2, and p of x less equal to means we can write 1 minus p of x is equal to 0 plus p of x equal to 1 plus p of x equal to 2. And we know that the value of the lambda is given 1.5. So here 1 minus p of x equal to 0 plus p of x equal to 1 plus p of x. So here we just put 1 minus e to the power minus 1.5 into 1.5 to the power 0 by factorial 0 plus e to the power minus 1.5 into 1.5 to the power 1 by factorial 1 and e to the power minus 1 into 1.5 whole square by factorial 2. And after simplification, what we get, that is the result. So I hope you understand the videos. So thank you.